We're here. Right.
So I don't think I can hear you.
I'll still mute it. So sorry, I'll start again.
Oh, that's much better.
Thank you so much for joining us again for yet another Azure Thursday. And tonight's session will feature two amazing speakers yet again. And in just a minute, Rohan Kumar, Corporate Vice President of Azure Data, will start this evening with a grand tour of all the limitless possibilities we have in the Azure Data platform. And there's so much there, so that's going to be an awesome session. And we're very excited he's doing this session with us. He could find the time in his schedule, in his probably very busy schedule to do this. And at 8, we have Ida Bergum, who is doing a session on analytics and insights in Microsoft Teams using Power BI. So I'm very much looking forward to that as well. That's going to be a very interesting one. So as always, we love to relay your questions to the speakers. So if you have a question, ask them in the chat, and we'll gather them and collect them and ask them at a set time, which will probably be at the end of the session due to the streaming delay we have. And we also have some bittersweet news regarding the next December edition of Azure Thursday, because December 3rd, we will not be doing a regular Azure Thursday. But instead, we have something even better, probably, that's more amazing. We have some even more amazing Azure content to share with you, because we'll be co-organizing the Benelux edition of the Virtual Azure Community Day. So definitely stay tuned on more info on that. And also I have the link to which of course I have to look here. It's the AzureData.Community link. So if you go there and keep posted, then you can add it to your calendar. And if Rohan is ready for us, then.
Yes, I am.
Very cool.
Hey,
Let me just go ahead and get my slides up here.
We're so very honored to have you with us here tonight.
really nice to have you, yeah.
Oh, thank you. Can you let me know once you're able to see my slides?
We certainly can see your slides. Yes.
Yeah. Perfect. So, first of all, again, thank you and hello, everyone. As I just got introduced, Rohan Kumar. I work for the Microsoft Azure Data team. I'm really excited to be here. One of the things that I try to do is community events like these, which are sort of so set up from just from the ground up, and in many ways, all of you are the ways in which we realize our vision and when we invest in sort of building out these data products. But the first, I want to start by saying a huge thank you to this community. You're coming together. I mean, it's just been such a challenging time over the last multiple months because of COVID. You're navigating the change and you're helping our customers, collective customers. So that's amazing. So just thank you. And today, I thought I'll sort of share some perspective on what is it that we're hearing from our customers. In my role, I land up spending upwards of, I'd say, 30-40% of my time talking to customers, understanding the challenges and the journey that they're going through, and how that sort of shapes our product investments. And the two areas I'm going to focus on are analytics and AI and machine learning, because it's a very broad portfolio and I have a limited amount of time, so it'd be hard to cover everything. But since it's becoming very clear, one of the things that comes up in my customer conversations is that predictive analytics using AI machine learning is such a critical element of every enterprise customer's digital transformation. Digital transformation, of course, is a pretty big buzzword. But if I had to sort of boil down to what is it that when we engage with the customers, what are the core scenarios that they're looking at from their business standpoint? First, believe it or not, is really every large enterprise, medium enterprise that I speak to, they always ask me, like, how did Microsoft transform itself? And how did you get to become, and I shared the journey that we've had about, going, building out our own modern data estate, right, to sort of become data driven at every level of employees in the company, and the intention there really was to make sure that at all levels of the organization, our employees feel that they have all the data they need to make their decisions that impact their work. So empowering people, and this is what we hear from our customers as well. Like they want to provide their employees with the best tools that helps them become a data-driven organization, right? So that's a key part. The other one, almost any customer you speak to in any industry now, especially even with COVID, it's become even more important, is to build out those connected experience. Everybody has some ambition towards creating an e-commerce site, a mobile experience, just given the proliferation of customer connections that are happening through those immersive mobile experience, and then using the feedback based on the actions that the customers take as a key input. So it's not just surveys that you do. You can literally track what is it that the customers are doing with your mobile app experience or your e-commerce site, to start looking at that as the clear feedback to transform your products, both from a capability standpoint or even looking at newer business models. I mean, there's a pretty interesting discussion that we have internally with Microsoft, within Microsoft, and with a lot of our outside customers is, as there's a lot of momentum towards I pay when I see value, how do multiple businesses evolve in those business models? So transforming products, transforming business models is an important thing. And then the ever popular one around optimizing operations, right? Like especially if you look at any IT organization, especially given COVID, they are looking at ways in which they can look across their value chains and see how they can optimize for costs, right? And one thing that I always share, I get asked this question all the time is, hey, has something fundamentally changed in terms of the customer investments? And what I will tell you is I've had discussions with multiple customers who wish, I mean, these are senior executives in these companies who wish that they'd actually expedited their transformation journey to become a lot more data-driven, right? Because at this point, one of the things they're struggling with is, okay, if we have to sort of navigate the next few quarters of uncertainty because of COVID, what are the best decisions we could make? And having that modern data platform, modern analytics and platform that has AI and ML deeply integrated lands up being very, very critical for that. So if anything, this pandemic has really put into focus for them that they have to do it to survive. Now, of course, the question essentially is, as we navigate the next few quarters, can we prioritize some of the investments that help us save costs by optimizing operations? So I just wanted to share that perspective with all of you to, before getting into the details of our product strategy and as to why, like what shapes are all up, product investments. What is it that we are hearing from our customers? Because this is really, really critical. And as we look at, if we go through the semester planning, where every 6 months we sort of, look at planning and execution. And a lot of the work that we do across all the data platform services is to ensure that we are able to support our customers as they're going through this journey. Right? So that's really key. Now, with that as the background, if I sort of jump into the core pillars, first of all, one thing that I feel really, really, proud about, frankly, and I say this with a lot of humility, is if you look at the breadth of our portfolio, right? I mean, we, about 10 years ago, I'd say, or maybe 11 years ago, the only product we had was SQL Server. I mean, of course, it's a fantastic database, and it's pretty much every customer in the world that we know of uses it in one way or the other. But when I look at where how far we've sort of come in just in the last 10 years, where in Azure, just the breadth of the services that we support, of course, SQL Server continues to be a pretty strategic investment for us, but all the work that we've done in Azure to bring managed SQL support, right? With Azure SQL Database, managed instance, the work we've done around hyperscale, serverless technologies. And then, we push the boundaries of operational databases to include open source, right? Where one of the things we started seeing is, for Azure, obviously we had a huge community of .NET developers who use SQL Server. It's about 7 million strong worldwide and growing pretty healthily. But we saw an opportunity to serve customers who came from the OSS background. So that's one of the reasons why we've invested pretty significantly in, Postgres, MySQL, and MariaDB on the same foundation for PaaS services that we, built from, converting SQL Server into a managed service in Azure. Then when you sort of move from there and look at, NoSQL becoming, a pretty fast-growing database technology, if you will, for a lot of the modern cloud-native applications. Really, when you look at developers who are looking at a data first, code first, and where they don't want to be constrained by having like strict definitions of schemas because of the evolution that they see in these data streams that they're able to handle. And so Cosmos DB was actually created, believe it or not, to support our internal services like Xbox Live. Microsoft Teams, for example, is completely built on Cosmos DB. Skype, our entire Azure portal experience, it's a single Cosmos DB database that's spread across 28 regions in the world. And we had very strict expectations around latency and throughput, right? In fact, Cosmos DB is the only operational database of any kind worldwide that doesn't just guarantee you financially backed SLAs on availability, but also on throughput and latency, which is very unique. And that really went into the design of how we partition the data across several nodes to support the true scaled out nature and what we did around geo-replication and such. We support a caching service with Redis, which is one of the most popular APIs to cache any sort of data in front of data stores, other data stores like operational databases, etc. Right? On the analytics side, of course, that's been a huge amount of learning, and I'll go a little deeper into the vision that we have around Synapse. Many of you may be aware we launched that a year ago, and it's just been phenomenal to see the growth. I've never seen any of our data services grow in that manner in terms of both customer interest and the consumption that we're seeing, as we've seen with Synapse. We significantly continue to invest in Power BI. It's a flagship service for us, when it comes to visualization tooling. And there is so much of value that we've added just to, do more than, just static reports, if you will. There's a lot of work we've done around supporting, predictive analytics inside of Power BI as well. Now, when I sort of come to hybrid, right, this is an area which, hopefully many of you are aware. When we got onto the cloud journey, it was very clear to us that, moving to the public cloud, while that may be a destination for most of the customers, the journey is not going to happen overnight, right? So it's actually interesting to see, we started off with Azure Stack, and now what we launched with Azure Arc, again, a little over a year ago, has sort of seen significant adoption as well, where, the goal that we had was both the application model and the business model that you get with cloud native services in Azure. How could we bring that to the environment of your choice? It could be a private data center, it could be some other cloud, a hyperscale cloud as well, as long as you have container as an endpoint on which we sort of build out our managed service portfolio. So all the tools, for example, that our engineering team uses to run these data services at such a large scale. For example, SQLDB today has anywhere upwards of 6.5 to 7 million active databases that get managed by a very, very small team of engineers. So we had to build in a lot of tooling, and we package all of that as a part of Arc. So hybrid's key. And then, finally, it's interesting. A lot of the modern application patterns that we see span the intelligent cloud and the intelligent edge, right? I think, remember Satya a few years ago launched this whole notion of how the whole application paradigm is changing very significantly, where the edge devices, frankly, from a data platform standpoint, are going to contain upwards of 65, 70% of all the data that's produced in the world. So for that, we basically, invested in getting the core SQL Server relational engine to work on ARM devices as well, like the Raspberry Pi. So we reduce the footprint while maintaining complete compatibility of the developer programming surface area. And we're seeing a lot of traction there. And we have examples of customers who are basically training their machine learning models in the cloud and deploying them onto Azure SQL Edge devices to basically use the SQL predict function that we have to do intelligent scoring and to make decisions on the edge devices, because the latency of the decision making needs to be really small. So that's another area where we invest pretty heavily to sort of cover up the spectrum. And then finally, an area where you'll see us talk a lot more, shortly here in the next maybe month or so. I can't divulge any further details there, but we see governance of data as a very, very huge opportunity to serve our customers. Obviously in Europe, you are very familiar with GDPR, and where in many ways that actually started the trend. We have an equivalent regulation that's building up in the US called CCPA, and almost every region in the world has very strict requirements around privacy of data, policies that you want to sort of apply on data and how, and governance and such. So that's an area that's very critical to our strategy as well. And you'll hear more about that. With that as the background, let me sort of, jump into analytics. Like I said, obviously I'm sort of, as a part of this presentation, I'm not going to cover all what we've done around operational databases. I mean, there's a lot that's gone in, but just given, the strategic direction that we're seeing with the core enterprise data warehouse, I thought it might be valuable for this community to hear our vision. Synapse, you may be aware we announced this, as for us, this is a flagship service for analytics inside Azure Data. And the key learning that went into building Synapse, before I get into the details of, the pillars that are called out on the slide, is what we observed, about 3.5 years ago. We basically stepped back and said, what are the friction points? It's clear from the business users that they want time to insight. Right? Like where once they decide that they need to make a decision, they need access to the data to give them that insights. And that needs to happen pretty quickly. It can't be like, several weeks or months. But that was the reality. If you look at, while there is a lot of excitement around predictive analytics, where, with machine learning AI within your data warehouse, the reality is 80% of the time and cost is spent in building up a reliable pipeline. That data integration piece, if you will, having connectivity to on-prem systems, legacy systems, SaaS applications. In many cases, you may want to get clickstream data out of your e-commerce website. If you have some sort of an IoT application set up, maybe there are devices that are sending telemetry data for you. And so just the whole setup was actually super complex, right? So with Synapse, one of the big things, pillars, that unified experience one that you see on the slide was very key, where we said, look, we need a single analytics service, not like multiple services that our customers need to stitch together, because that's what's causing the friction. That's really what's causing the time to be, several months. And if we can sort of create a service that essentially brings together the data integration capabilities, data warehousing capabilities, big data analytics into a single service as measured by, let's say, setting security, monitoring, governance, dependency tracking, availability, etc., where as a customer, as a data engineer, you have a very simple no-code experience, then that could be game-changing. So that was the vision, behind Synapse, and obviously from a scale standpoint, we basically had, like petabytes, tens of petabytes as like the minimum data point. Now, just to give you some perspective, Microsoft's own analytics platform, that's one of the things that my team supports, is upwards of 10 exabytes of data that's essentially running on Synapse today. Right, and so of course we have a team that sort of supports it, builds it to enable that scale. But fundamentally, we basically wanted to design Synapse to essentially have limitless scale. Right, I mean there's upwards of certain when you get into several tens of petabytes, there's certain other considerations, but we didn't want the service to have any limits when it comes to that scaling out and supporting very large volumes of data. The powerful insights, and you'll see as I get into the next slide to talk a lot about it, we've deeply integrated Synapse with Power BI and Azure Machine Learning, just to create a very seamless collaboration experience between data engineers, business analysts, and data engineers with data scientists who want to use process data to train, experiment on the data sets. I spoke about the unified experience. And then finally, of course, security is so paramount because some of the most high value data is covered, coming as a part of the analytics platforms. And you'll see this where this was a key requirement that our customers wanted. Now, this slide, gets into a little bit more detail in terms of, the layering of the stack. Azure Data Lake Storage, which it's an object store that supports an HDFS API. That's really, designed for very, very large volumes of data to be managed at scale in a very cost-effective manner. The two runtimes we've bet on are SQL, T-SQL, and Spark, because T-SQL, of course, for the data engineering community is very, very popular. And Spark, as we see among the data science community, is sort of taken off in a pretty major way. We support batch workloads today, but we're working essentially on adding streaming. Sorry, it's sort of a little ahead. We're working on adding streaming workloads. So you can imagine, some of you may be familiar with Azure Data Explorer. It's a database that we have to support log analytics, streaming, event hubs. That also supports the Kafka API, Azure Stream Analytics. Just like we got data integration, data warehousing, and big data analytics, we're going to get the streaming workloads, the real-time workloads as a core part of Synapse as well. So, within the unified experience. Now, it's interesting if you look at what we've done with Power BI, where just within Synapse Studio, you can create Power BI reports, you can create enterprise-grade semantic models without ever having to leave, that unified experience. And then the integration we've done with Azure Machine Learning enables data scientists to automatically, work on the data sets that have been processed by Synapse, run their experiments either through Jupyter Notebooks, you can write Python code, or you can in AML, which is sort of like the one-stop shop for analytics, you can use the automated ML workflow to train your models. And once your models get trained and you pick the one that works best for your scenario, you just register it. Then automatically within SQL and Spark queries, you can use those models for scoring purposes. So it's a very, like I said, when a lot of customers ask me, how do you compare analytics with others in the market? And I always tell them there is no other service that does everything what Synapse does. You can take pieces of it, right? You have some provisioned warehouses, you have serverless queries, that's some support. There are some services that do data integration, but Synapse essentially brings together the end-to-end pipeline in a pretty seamless manner. So that actually I'm super excited about. Synapse Link, this is the next set of innovation that we announced onto Synapse earlier this year at Build. And the key problem there we tried to solve was the deep integration between our operational databases. Starting with Cosmos DB, we are bringing this to SQL DB, SQL Server, Postgres, etc. Where the idea is we wanted to reduce the friction of basically supporting analytics, real-time analytics on your operational transactions as they commit. So our goal really is within 30 seconds of the transaction committing, that data should be available within Synapse to run your machine learning experiments, etc. Now that's really important, for if you look at scenarios like, you want to learn in real time based on your customer interactions, let's say on your e-commerce website or the application that you've provided on the mobile phone, where you presented a certain set of offers to them, and let's say they declined it. There were some search results that they came up and that didn't convert into a sale. You want to learn from each action like that is a very key data point. And not weeks later or months later, but in real time, because that's really what's going to change the game. That closed loop between your line of business application that's committing the operational transactions, that data landing in Synapse, you're training the models and putting the newly trained model, which took that insight into your system, back into your e-commerce system, that improves the experience for the customer. So that's truly where Synapse Link comes together. Again, it's the cloud native HTAP. There's no other cloud that has anything close to it today. And we're seeing a significant amount of, again, uptake from customers who've used our operational databases like Cosmos DB as an example, because of the simplicity that Synapse Link has created for them. Let me sort of speak about a customer, NeoGrid. Now this is one of the customers that we've had who basically use Synapse to completely transform themselves. Right? It's an information service provider for top retailers such as Walgreens, Walmart, and manufacturers like 3M, Adidas. And unlike a traditional data warehouse that handles data within one corporation, NeoGrid actually collects data from several retailers and in turn serves more than 580 manufacturers. Right? So they're relying on like an old legacy, costly on-prem data warehousing solution, and they're running into lots of challenges like limited disk space. There was end of support requirements. They didn't really have a good disaster recovery solution, which was very, very painful. And they also, more and more, their customers started demanding more real-time, analytics, and the lag. The system was just not able to handle that, and so they made a huge bet on Synapse, and it's like significantly changed the game for them. Their entire analytics process, they're able to generate powerful insights in near real time for their customers, and at the scale, it just basically works for them. And all their on-prem, warehousing solutions that contain retail, manufacturing, logistics data is all ingested into ADLS and then processed through Synapse, to produce insights. It's a pretty amazing story of how this thing has succeeded. Now let me sort of move and go into a demo to actually show how Synapse and everything comes together. Are you able to hear it? Just making sure that.
operations. To improve this and increase business efficiency, Lisa needs to incorporate real-time customer purchasing data into her existing Synapse Enterprise Data Warehouse. She'll use this data to develop a predictive model and then socialize these predictions with her peers using existing tools and, of course, existing skills. Azure Synapse Analytics is the evolution of the data warehouse. It is a fully integrated analytics platform that provides data integration and analytics capabilities for SQL and machine learning through an intuitive web-based development experience. The platform provides both code-first and code-free interfaces that enable developers of all roles to be productive and unlock new insights from any data and at any scale. Lisa determines that by supplementing her existing data with real-time point-of-sale data and other operational data, she can more accurately predict product inventory requirements. Since contesso retail point-of-sale systems run on Cosmos DB, Lisa can enable a real-time feed of this data into Synapse via a single click in Azure. This data is now available for analytics in Synapse without building any data integration pipelines. Lisa isn't a data scientist and doesn't have the skills to determine the optimal machine learning model for her scenario. With Synapse, Lisa can incorporate this real-time data with existing analytics data, and using the native link to Azure Machine Learning, she can apply AutoML to identify and train the right algorithm for this scenario. The final and most important task is to empower her team with these improved insights. Using Synapse in-engine SQL scoring, Lisa can operationalize her new predictive model directly within the Enterprise Data Warehouse. This enables the entire organization to easily visualize the new inventory forecast in their existing BI tools. And because a lot of this data is sensitive, the native row-level security and data masking is honored when the predictive model runs, so that no one has access to data they shouldn't. Using native integration with Power BI, she can author and edit reports within Synapse and share the insights with her team. With Azure Synapse, Lisa was able to quickly deploy an improved inventory forecast solution using real-time data. The SQL interface provided predictive insights to all existing business intelligence tools. No additional training or applications were required, and all existing data security was maintained in the solution.
Hopefully that gave you a good sense of the various capabilities of Synapse and how they come together. Now let's, if you really look at what's the ultimate goal of having all this data, processing it, it's really to get important insights to help drive your business forward. And part of this is also being able to predict based on all the historical data and trends that you're seeing, what decisions to make for the future. Depending on the vertical that you are in, it could be equipment failure predictions, anticipating customer needs, or maybe forecasting some catastrophic events. And over the past few years, we've seen an incredible transformation of industries as they're harnessing the power of AI to transform their business. And AI ML is pretty much baked into all data products that we have. It's customizable, it's repeatable, and it really changes the way a lot of the decisions get made based on the insights. Now, one of the things, what we've sort of seen, from our customers is our Azure AI customers are using machine learning to build predictive models, of course, and optimizing their business processes as an example, and storing these models inside the data services. They're also using advanced vision, speech, language, and decision-making capabilities to build out the AI-powered apps and agents to deliver personalized experiences. So for a developer, it's actually as simple as calling just an API, and all the complexity of training those models, making sure that they have the best predictions, are all sort of hidden from the developer. And we have customers who are applying a lot of AI services at scale, like knowledge mining. So this is an area where they're able to uncover a lot of latent insights from vast repositories of data, where those those relationships, the causal relationships that may lead to something which are very, very hard, to figure out without having this depth of the AI knowledge. Now, while all this is great, the big trend that we see when we talk to our customers essentially is this whole notion of designing trustworthy AI. When more and more of decisions are going to be, based on this predictive analytics, a major challenge is how do you build that in a way that the inner workings are very well understood? Why did the model make this decision? How do you ensure that any of the models that were trained on data sets, are they fair or biased, right? Like, how do I basically train AI models on sensitive private data without leaking it? A great example here is mortgage lending. Consumers and lenders alike want to ensure that the models in that vertical being used in their predictions are both avoiding any unintended biases and protecting privacy of customer data. And of course, how do you sort of look at regulations and stay compliant with that? So we've invested very heavily in our Azure AI services towards responsible AI. And let me actually sort of bring in Sarah, who's going to demo how all of these things work and come together.
Hello, everyone. Today, I'm going to be walking through a demo of some of our responsible AI tools on Azure. As we progress through the ML lifecycle, I'm going to be demonstrating 3 key capabilities: protecting sensitive information with differential privacy, assessing and improving model fairness with FairLearn, and analyzing and explaining model behavior with InterpretML. In this demo, I'm going to be building a model for loan applications to decide which to accept and which to reject. Let's dive in. Here I'm using Azure Databricks, but you could also use a Jupyter notebook or your favorite Python environment. Like any good model building scenario, the first thing I want to do is look at my data. Here I'm looking at aggregate information as well as individual features to help give me a feel for the data set and uncover any potential issues up front. It looks like this data set contains a lot of great data to help me build my model. It also contains highly sensitive information that must be kept private. Obviously, I can limit direct access to the data with the data store. However, what many people don't realize is that aggregate values can still be used to reveal private information about individuals. Let's go to an example to see what I mean. So here I'm going to demonstrate how we can use aggregate information to reconstruct the data set. So in this case, I'm going to assume that I know aggregates about individuals' income, as well as a little bit of additional information about 2 individuals in the data set. And with that, I can take an off-the-shelf SAT solver and use that to reconstruct a data set that's consistent with the information that we know. So if we run our SAT solver here, it's working to reconstruct that data set, and we see that it can actually find a result. And now we're going to compare that to the real data set and see how well our attacker did. So in this case, it looks like the attacker did pretty well. We're able to correctly reconstruct the incomes of individuals within $5,000 for more than 20% of the data set, which could be a significant privacy violation. So what do we do about attacks like these? How do we use data but still protect privacy? And this is where differential privacy can help. So differential privacy hides the contribution of individuals in the output computation by adding a small amount of statistical noise to the query. The noise is significant enough to protect the privacy of individuals, but often small enough to still allow us to use the data. Differential privacy also calculates the amount of information that is revealed in the query and subtracts that from an overall privacy loss budget. Let's look at how this works. So here I'm going to use our open source differential privacy platform, and now I'm going to add that statistical noise to the income information. And then I can retry my attack with my SAT solver. And what you'll see here is that we get a very different result. We aren't able to reconstruct a data set that's consistent with the differentially private incomes. And so we don't have any guesses at any private information. However, it's not enough to just protect privacy. We still want to be able to use the data. So let's look at how we're doing here. In this case, you can see that we're looking pretty good. We're pretty close to the original information. You can definitely see some noise added, particularly because this is a small data set. However, now I can take this and go and use it in my problem, knowing that I don't have to be concerned about privacy attacks. So one of the ways that we can use differential privacy in machine learning is to generate synthetic data sets. So here I'm going to use my open source toolkit, and I'm going to create a data set that matches the patterns and trends of my original data set, but doesn't reveal any private information. And that way I can take that and give it to my data scientist without having to worry about privacy. So I'm going to generate my data set here. And now that I have my private data set, I can go and build my model. So here I'm going to build a scikit-learn model for my problem. And now that I've built the model, I want to actually analyze the performance and see, is it good enough for my problem? So of course, I can look at traditional metrics like accuracy. However, since this is a problem where a wrong decision could have a significant impact on an individual's life, it's important that I go a step farther and I also consider the fairness of my model. So in this case, I'm going to use fair learn so that I can understand how well my model works for different groups of people and make sure that it's not using sensitive attributes to make decisions. So in this case, I'm going to use fair learn, and fair learn has an interactive dashboard to help me better understand the fairness assessment. So I'm going to click Get Started here, and my data set has two values, sex and race. So let's click into sex and understand how well my model's doing. But I also need to provide a performance metric, which metric's important for my problem. So in this case, it's accuracy. So I'm going to click through. And the first thing I have is a graph here that helps me understand the difference in model performance across these two groups. So I can see that my model's more accurate for women than men, and it's about 85% accurate overall. However, I'm really interested in the outcome of this model. What's the difference in who I'm offering loans to? So in this case, I can see that I'm offering loans to 19% of people overall. However, I have a significant difference in the number of loans I'm offering to women and men. I'm offering loans to about 7% of women that apply and about 25% of men that apply. Now, I don't necessarily know if this is a problem. It could be that these two groups have very different distributions. However, I do know that it's a sign that I want to dive in and investigate further. So for that, I can use Interpret ML and its black box explanations. So I'm going to generate explanations for my model here, and then I'm going to use its interactive dashboard to explore those and understand how it's making its decisions. So in this case, I'm going to set up two different cohorts. So let's set up one for women so we can understand what's going on there. So I'm going to add a filter for sex, and women are 0 in this data set, so we can add this filter, and I'm going to save. Then I'm going to add a second cohort here for men, and I'm going to select this. And in this case, I'm setting up for men and women since I want to look at this fairness problem, but you could use lots of different cohorts like train and test to compare as well. So in this case, what we can see is the model performance, just like we saw in Fair Learn, but in a lot more detail. However, what I want to do here is jump over to the explanations to understand the feature importance and how the model's making decisions. And what I can see right away is that the model is using sex directly as a feature to make predictions for women, but not necessarily for men. And if I click on this, I can actually dive in and see that for women, for every single woman in the data set, the value of sex being 0 is directly contributing to the prediction that they are rejected, which is pretty concerning. And so what I want to do at this point is move on and explore mitigation techniques. So for that, I can go back to Fair Learn and use some of the built-in mitigation algorithms that allow me to reduce disparity either during training or after. So in this case, I'm going to use the grid search approach where I'm going to retrain many different models by reweighting the data to try to reduce the disparity. So I've run my model training here, and now I can go back to the FairLearn dashboard to look at the best models. So in this case now, I have a range of models that are along the curve of difference in predictions and accuracy. So here's my original model up here. And now I'm actually going to click through and look at this model, which is a little less accurate, about 82% accurate. But if I jump down to the disparity in predictions, I can see that I have a much different outcome. Now I'm offering loans to 15% of men and 14% of women that apply. So this might be a much more promising model for my problem. And so what I'm going to do now is actually save all of my work so that I can share it with collaborators or show it to other stakeholders as we make a decision about whether or not we want to move forward with this model. So I'm going to register all of my models here. I can upload my dashboards and my explanations, everything to Azure Machine Learning. Then if I move over to my Azure Machine Learning Studio here, then I can click on a particular run. And so here's my different runs, and I can click into one. And now I can actually have my dashboard stored directly with my model, as well as the fairness. And so now I can show this to other stakeholders or compared to previous models as I decide whether or not I want to take this into production.
Hopefully that sort of gave you a good sense of the whole end-to-end experience, let's say for a data scientist as they're sort of working on looking at the results of the predictions from the model, and then that transparency which helps them detect if there's any bias, and then take steps to mitigate that bias to ensure that the model is fair, and the critical decisions that are being made by the model. Because I mean these. Look, I think that we're moving towards a world where a lot of these predictive analytic decisions are going to define whether somebody gets a house loan, what grades they get, which schools they get admitted into. I mean, we've seen that happen recently in Europe as well. And so these are very, very impactful decisions. And that's the reason why we're investing so heavily to make sure that responsible AI is a very critical anchor point of how we think about our AI services. The final chapter I have around governance, I sort of spoke about the importance of governance of data. The big thing I'd like to call out here, and you'll hear a lot more, like I said, in the coming months, is our target really is the chief data officer, because who's responsible, or the chief privacy officer, depending on the company, the titles could be different, but they're responsible to make sure that all the regulations are complied with the data that the company has. And they need to answer questions around discovery, like what data do I have, where did it originate, can I trust it, like who changed it, all the lineage tracking, classification, etc. And then the governance piece, what's my exposure to risk, was there any compliance issue related to GDPR that was violated, how do I set governance policies of who can access what types of data, especially when it has PII information, can I do things to, like mask certain data sets. So there's a huge, set of complex questions that need to be supported. And that's really, the platform that we're building. What we have today is a piece of the puzzle. It's very important, which essentially is the Azure Data Share service that works with all our data services like storage, Synapse, etc., to ensure that you can share data between an organization within different divisions or across organizations with a lot of security. It essentially, there's the ease of use. There's flexibility where you can sort of say things like don't copy the data, and restrict the number of queries that you can run against it and such, just to ensure that you're not leaking too much, and then expand the analytical data sets as well. Now let's sort of go to a demo to actually show how Azure Data Share works.
Contesso operates more than 1,000 retail stores worldwide and works with more than 10,000 suppliers. Their business operations depend on timely sharing of sales, inventory, and forecast data with their supply chain. As their business grows, it becomes increasingly challenging to manage data sharing at scale with their large number of suppliers. Lisa's team manages sales and inventory data preparation and shares these insights with their top suppliers. John is a data engineer at Fabricam, a supplier to Contesso. John receives data from Lisa on a regular basis and combines this data with other data for forecast and planning. With Azure Data Share, Contesso can easily and securely share data at scale with their supply chain without the need to set up and maintain additional infrastructure. Using Azure Data Share, Lisa shares data with John with just a few clicks. To create a share, Lisa first specifies the share name, the mode of sharing, either snapshot or in place, a description of the data, and a terms of use. Next, Lisa selects what data she wants to share. She has the flexibility to select data from a variety of data sources, including sales data from Azure Data Lake Storage and inventory data from Azure SQL Database. Lisa specifies John from Fabricam as the recipient. With snapshot sharing, Lisa can configure a schedule to provide automated updates to ensure Fabricam gets up-to-date data on a regular basis. After the share is created, John receives an email notifying him that Lisa has shared Contesso data with him. Following the link in the email, John can view the details of the invitation, agree to the terms of use, and accept the share. John has the flexibility to choose where and how he wants to consume the data. He decides to receive the data as files and folders in Fabricam's Azure Data Lake Storage and enables scheduled update. With this turned on, Azure Data Share automates ongoing snapshots of the data from Contesso to Fabricam. By connecting Azure Data Lake Storage to Azure Synapse Analytics, John and other data engineers at Fabricam can explore the data using a familiar analytics engine such as SQL On Demand or Spark. They can combine their in-house data, Contesso data, and data they receive from other retail customers to perform forecasting and planning analyses, turning data into insights within minutes. Lisa can centrally manage Contesso's data sharing from a single dashboard, keeping track of what data is shared with whom and when. She can also receive data from suppliers seamlessly. There is no longer any need to set up and maintain additional infrastructure. With Azure Data Share, Contesso delivers data to their suppliers in a timely manner with minimal overhead. This creates more agility for their supply chain operations and enables faster time to insights. It allows Contesso to quickly adjust to changes in customer demand, resulting in optimal stock level and reduced operational cost.
Hopefully, that was sort of the final demo, and we sort of spoke about an element of what we are trying to do with our governance platform, being sharing of data. And I just wanted to close back the way I started with talking about the 4 pillars of the digital transformation, which effectively guide a lot of the investments, like I said. And it is really a fantastic opportunity when I think about the role all of you and a modern data estate is going to play. Our customers need the help, to transform themselves digitally, to sort of really take advantage of a lot of the power that the cloud offers, the hybrid technologies offers, and analytics and governance of data, frankly, is going to be at the center of a lot of these, customer transformations. And, we'd love to keep, hearing the feedback from the community on how we could do better. And again, thanks for everything that you do and all the feedback that you give. So with that, maybe let me hand it back and see if there are any questions.
Thank you, Rohan, for sharing this. Such amazing developments around the real-time processing with Synapse links and all the other things you shared. We'll definitely stay in tune for those announcements regarding the governance in the next month. So we're very much looking forward to that. And we certainly have some questions as well, and we probably can't ask them all. But we got one question from the speakers from last month's edition, and it was concerning Azure Synapse. and Databricks, because Microsoft announced Azure Synapse last year.
Right.
And we also have Databricks. So are there any plans for the roadmap? Because, well, Microsoft promotes both, but they have similar options. They seem to solve similar problems. Are we going to still have both? I think that's the question.
Yeah, so a couple of things. What I'd say is, if I sort of take a look at, there are multiple personas we are trying to solve for, right? Like with Synapse, the vision that we had was, across the board, like how do we simplify everything that happens in the analytics pipeline with a single product, right? And of course, this includes, we have data engineers who use SQL a lot for their transformations. They're basically, scientists who want to sort of use Apache Spark, for some of their data science workloads and the whole integration that we've done. Now, there are customers, who basically want everything Spark, right? They just want a premium Spark experience. And we have a fantastic relationship. It's a first-party service with Azure Databricks. So you're right. In a lot of these cases, what you'll notice is that there is some amount of overlap that may happen, but it's essentially to serve the needs of the customers that they have. In this is the case. You almost pick HD Insight as an example, which is another service which is targeted towards more lift and shift of your existing Hadoop environment. Does it have Spark? Does it have Hive, etc. that you can do your warehousing on? Yes, but it is very tailored towards a specific scenario. So what I would suggest is the way we sort of think about these product innovations is we always go from customers, what are they familiar with? As we start thinking about Babylon, that will be deeply integrated with Synapse, and it's a thing that we're moving forward towards. And then as we move, we'll always listen to customers and see if there are better integration options. For example, even with Synapse, if you want to use a different data integration story, you can. If you want to use Databricks for Spark by using SQL inside Synapse, you can do that, right? So there is the extensibility is always there, but we just wanted to provide an option in Synapse for our customers so that that true integrated experience comes to life.
Perfect. So we have absolute freedom in which tool we choose.
Absolutely.
Absolutely. Perfect. Thank you. I think we have time for one question. I think that's a small one because we have Azure Synapse Workspace, which has been in preview for a couple of months now, I think. Is there anything to tell us on the roadmap, and that will be available?
How about, I'm not... It is, of course, as you know, specific dates are always a little confidential, but I really like this community. Yeah. So how about just wait a month?
Okay. Thank you so much. That's a very good answer. Oh, I want to thank you again for sharing this content and for this amazing session. And I think that's all the time we have, because in a couple of minutes we have Ida Bergum that's going to show us around and how to use this amazing data platform to do analytics and insights around Microsoft Teams using Power BI. So that will be a very good one as well.
Oh, that's fantastic. I'm sure Ida's session is going to be great. And again, I do want to thank the community. I hope, I did want to share a little bit of the customer perspective so that all of you understand what guides, our strategy and product innovation. But, if there's one thing that I leave you with is, there's few times in one's life where this opportunity comes up. And I actually think as data professionals, all of you are, fairly fortunate, I must say, to be, having those skills at this point in time in the world, because it is going to be super relevant in every vertical and every customer. So again, thanks for the great partnership, and you can count on us to sort of listen to your feedback and make changes that help you solve your customers' problems. So thank you.
Excellent. Thank you so much.
Thank you very much.
And now we have, I think 2 minutes to grab a fresh cup of coffee.
Yeah.
We'll be back in just a couple of minutes with the session from Ida. And first we have a word from our sponsors, I believe.